Okay, now we're on section 3.11 and we're doing question 1, and we have to find the linearization of this at a equals 2. In other words, a line that will approximate the values of f of x near x equals 2, and the linearization formula is L of x equals, for some a, f of a plus f prime of a times x minus a, and as we're going to find out, that's going to become f of a plus f prime of a times dx, the change in x, which ultimately, as we will find out, is f of a plus dy, the differential. But anyhow, let's get on and just find the L of x for now. So we'll find f of 2, I beg your pardon, f of 2 equals, and replacing x with 2, 2 cubed is 8, minus, and 2 times 2 is 4, and we have a plus 3 there, and so that's going to equal 7. So now we know f of 2 equals 7. Let's find f prime of x. And that equals, by the power rule, 3x squared minus 2. And so f prime of 2 equals 2 squared is 4, and 3 times 4 is 12 minus 2, and that equals 10. Now I think we're ready to go. So L of x equals, we can make our substitutions, f of 2, in fact, let me write it down this way, f of 2 plus f prime of 2 times x minus 2. Okay, so L of x equals, and f of 2 is 7, plus f prime of 2 is 10, so we'll put a 10 here, times x minus 2. Now we'll expand that, and we get 10x minus 20, and that equals 10x, and 7 minus 20 is negative 13, and that's what L of x equals, the linearization of that function at x equals 2. So delta f equals this. Now let's do, this was a, by the way. Let's do b. And for b, we have to find df. Well, the first thing we have to find is the derivative of this. So given that f equals this, f prime of x equals 3x squared minus 1. And so f prime of 1, replacing x with 1, we get 3 minus 1 is 2, and so df equals f prime of 1, which is 2, times dx, which is 0.1, and we get 0.2, and there's our df. Now let's do part C. And so we have to find the absolute value of the difference of these two. So we're talking about delta f is 0.231, df is 0.2, and the difference of those two, the absolute difference, is 0.031, and we're done with that. Well, now we're doing question 53, and we're told that we've got some cylinder, and you can see the picture, and it has a height of 30 inches. It has a radius of 6 inches, but that radius is going to change because we want to know what we're given the thickness, so that radius is going to go from 6 inches and be all the way down to half an inch. So it's going to change. And so why don't we say thickness? K-N-E-S-S is 1/2 an inch, 0.5 inches. So now the volume of a cylinder, is V equals pi r squared h. But h in this case has the radius has no bearing on what the height is, so we can simply replace h with 30 and pi r squared. But the radius is changing as we go from the outside in to accommodate the thickness. So let's find the derivative of this, dv dr, and what we get is 2 pi r. Well, 2 times 30 is 60 pi r. And now let's multiply both sides by dr, and now we've got the differential of v, and that's going to be 60 pi r dr. Now our thickness is the dr, that's change in r. And so replacing pi, or r with 6 and dr with 1/2, we get 60 pi r, excuse me, I've got to make that a 6 times 6 times 1/2. Well, 2 goes into 6 3 times, and 3 times 60 is 180. And there's our pi, and that's going to be inches cubed. And if you run that through a calculator, you get approximately 565.5 cubic inches. And so we just made an approximation of what that change in volume would be, which corresponds to the volume of the material it took to create that pipe.